Hello everyone. So this is last session in IP address. So we have finished part 1, part 2, part 3 and this is the fourth part. So we have very small uh, topic here. So here we will discuss reserved IPs. Reserved IPs. What are the reserved IPs? In class A, class B, class C. In class A, we have some reserved IPs. Means reserved IPs means we don't use those IPs. We can't use. And class B also we have some IPs. And in class C, we don't have reserved IPs. So in the class D, or all IPs are multicast IPs. In the class E, also research and development. Okay, so here we have class A and class B important. Okay, in reserved IPs. So in class A, class B, see here, what is the class A range? The class A range is 0 to 127. Roughly it is 0 to 127. But if you want to give full clarity on range, so it is 0.0.0.02 127.255.255.255. Class B 128 to 191. So 128.0.0.02 191.255.255.255. In the class C, we don't have any, but class C range is okay. Class C range is 192 to 223. Same here also 192.0.0.02. 223.255.255.255. Don't discuss about the class D and class C, okay? Just okay, these are the classes, right? Class A, class B, class C, and ranges. So in class A, okay, now reserved, right? In class A, 0.0.0.0 series we cannot use. It is invalid IP. Invalid IP series like 0.0.0, 0.0.1, 0.0.0.2, 0.0.3, like that. We can't use this. If you try to configure this IP address in system, we can't use. See, I will show you here. So go to here. Here command is ncpa.cpl, and here try to IP address on any one network interface, network card, right click, properties, and here IPv4, okay, Internet Protocol version 4, and here configure IP with 0.0. See, it is not valid entry. It's showing directly 0 is not valid entry. Please specify a value between 1 and 223. 1 and 223 means up to class C only. Up to class C only. Okay, so we cannot use 0.0.0, 0.0.1 like that, right? So another IP is in class A 127.0.0.1. 127 series also we cannot use. This series is reserved for loopback IP. Loopback IP. Loopback IP is used to testing purpose. It is troubleshooting purpose. Simply say it is a troubleshooting purpose. Troubleshooting means to verify whether our network card is working or not. Our system LAN port, our system network port is working or not. That is the purpose of the loopback IP address. How to use this IP address? Now here, the first to go to command prompt. So here, ping 127.0.0.1. 127.0.0.1. Enter. See, we are getting response. If we get response, which means our system network port is working. You can also use 127.0.0.1. We can also use 127.0.0.3. We can also use any IP address starting with 127. 127.100.100.100 also. It's working, right? Or we can also use like this, ping loopback directly. Ping loopback. Enter. See, we are getting response. But it is what? It is IPv6 loopback. And if you want to IPv4 loopback, here we need to mention -4. -4 means IPv4. See, we are getting response from 127.0.0.1. This is purpose of the loopback IP address. So in the class A, we have 0.0.0 and other one is 127.0.0. Any IP address starting with 127 is reserved for loopback. What is the next thing? The next thing is one second. The next thing is okay. So now tell me here. Class A, we cannot use 0.0.0 and we cannot use 127.0.0.1. So now what is the class A range? The class A range is 1 to 126 only. It is not 0 to 127. Whenever if the interviewer asks what is the class A range, the answer should be 1 to 126, not 0 to 127. Because we cannot use 0.0.0.0 series. We cannot use 127 also. See, if you try to configure IP address 127 in the system, see what we will get. So now go to network properties, here right click and properties and select IPv4 and here try to configure IP 127. See, IP address starting with 127 are not valid because they are reserved for loopback interfaces, loopback addresses. Please specify some other valid value between 1 and 223. We cannot use 127. So class A range is 1 to 126. Okay, remember this point. Next, in class B, in class B, in class B, in class B, 169.254.0.0 to 169.254.255.255. This range is APIPA. This range is what? APIPA. APIPA stands for automatic private IP address. Automatic private IP address. Automatic private IP address. So, but what is the use of this APIPA address? As we discussed in the first lesson, IP address lesson, how many methods are there to configure IP address? We already discussed, right? So there are two methods to configure IP address. One is the static method. The second one is dynamic method. Static means assigned by administrator. Dynamic means assigned by DHCP server. DHCP server. DHCP server. Okay, now we will discuss about this dynamic configuration. So here, for example, I have some computers, computer 1, computer 2, computer 3, computer 4, computer 5. Along with these 5 computers, I have a server. This is the DHCP server. In DHCP server, there are some IPs. Okay, this is called scope 192.168.1.12, 192.168.1.100. This is the scope in server. The server IP address is 192.168.1.1. This is the first IP, server IP. So here we configure this IP manually, static IP address. Servers are always configured with the static IP address, right? Okay, right. And these all computers are connected to one network switch, like this. Like this. This is the network switch. Okay, we will discuss later what is the switch. So just okay, this is the switch. So here total how many computers are there? Total 6 computers are there, right? Including server. This is the computer 1, computer 2, computer 3, computer 4, computer 5, and the server, DHCP server. So here we have a server. So we cannot configure IP address here manually, right? So we don't configure IP address manually. So we can get the IP address from the server. So for example, this is the PC. If this PC wants to receive IP address from server, this PC first need to send one request message to server. Then only server will give IP address from 1.2 to 1.100, any one IP address. Server will not provide IP address automatically. Server will provide IP address only when it receives request from any client system. Remember this point. Client system is these systems are client systems. But my question is here. Okay, my question is here. How this client PC will get to know who is the DHCP server? Here there are 6 computers. In 6 computers, one computer is a server. That is a DHCP server. But how this PC know that 192.1.1.1 the DHCP server like that? This PC doesn't know actually. But in my network there are 6 computers. But in this 6 computer, what is the DHCP? Who is the exact DHCP server? This PC doesn't know actually. But how this PC will send the request message to server? To get the IP address, the first this PC should send the request message. So here to send the request message to DHCP server, the first this PC discover who is the DHCP server in this network. So first this PC send the one message that is called what? Discovery message. Which message? Discovery message. This PC sends one discovery message. Discovery message means nothing but what? It is asking everyone who is DHCP server. So this DHCP discovery message is what message? This is the broadcast message. This message what? Broadcast message. Broadcast message. So this PC sends one message. Broadcast message means this PC asking everyone in the network who is DHCP server like that. So this discovery message will be sent to here and to here and here and here and server also. But this PC cannot respond, this PC cannot respond, this PC cannot respond, this PC also cannot respond. Because these 4 computers cannot understand that message. So only the server will understand that message and server will send the response message. Yes, I am the DHCP server like that. Like this. Server will send the offer message. Server will send what message? Offer message. Yes, I am the DHCP server. So what do you want? Like that. It is asking client. Okay, I am the only DHCP server. So what do you want? Like that. It will send the offer message. Then the third one is client sends request message. Client sends request message. Yes, I want one IP address like that. So finally, server will send IP address with acknowledgement. This is communication between DHCP client and DHCP server. Remember points here, okay? So server will not provide IP address automatically to clients. Server will provide IP address only when it receives the request from the client machine. Right? So first, remember this thing. The second thing is, so first client needs to discover who is the DHCP server in the network. So client also doesn't know who is the DHCP server. The first client PC will discover. First client PC needs to find out who is the DHCP server in this network. So how it will find? It finds by sending discovery message. Discovery message is a small message. This is the DHCP message. The discovery message is a broadcast message, which means every computer receive that message. Every computer. If we have a 200 computers in the network, every other 199 systems receive that message. If we have a 500 computers, remaining 499 computers will receive that message. If we have a 1000 computers, remaining 999 computers will receive that message. Every machine will receive that message. Okay. So discovery message is a broadcast message. Second one is, if DHCP server will send the offer message. Like, I am the DHCP server, so what you want, like that. The server is asking client, okay, I am the server, what you want. The third one is request message. Client send the request message. Yes, I want one IP address. Please provide the IP address, like that. So finally, server will send the acknowledgement. This is process. This process is called DORA, D-O-R-A. Discover, offer, request, acknowledgement. This is very, very important in interview. Discover, offer, request, acknowledgement. Remember this process, very, very important in interview. What is DORA process? Discover, offer, request, acknowledgement. D means discover. Who send discover message? Client PC. Who send offer message? Server machine. Who send the request message? Client machine. Who send acknowledgement? Server. Right? This is the successful communication between the DHCP client and the server. So sometimes what happen? Client will send the discovery message. After sending discovery message, client will be receiving response, like waiting for the response from server. Means response means offer message. Sometimes what happen, due to network issue, for any reason, client will not get the offer message from server. That time what happen? Client has sent discovery message, but it is not getting offer. Maybe the DHCP server is maybe unreachable, or maybe network issue. For any reason, after sending discovery message, if your client PC is not getting response from DHCP server, what happen? Then what happen? The client will automatically assign one IP address. That IP address is called APIPA address. The IP address range is what? That APIPA address range is 169.254.0.02, 169.254.255.255. This is the range, right? So from this range, any one IP address will assign automatically by client itself. Whenever offer message is not getting, remember this point. So here what happened? The system will assign 169.254.0.10 or 0.11, 0. Whatever it may be. But remember here, any IP address starting with 169.254. Remember this one. APIPA always start with 169.254. Very, very important. Okay. But what is the use of this APIPA address? Now we will discuss that. Okay. Now see again. PC1, PC2, PC3, server. Server has some IPs 192.168.1.2 to 1.100. The server IP is 192.168.1.1. These four computers are connected to one switch. One second. I will draw clearly. PC1, PC2, PC3, and server. The server has some IPs 192.168.1.22, 192.168.1.100. Server IP is 192.168.1.1, and these four are connected to switch. For example, just assume PC1 has received IP address from server. The IP is 192.168.1. PC2 has also received IP address from the server, that is 192.168.1. But when PC3 sends discovery message, server is not responding. What happened here? PC3 will automatically assign the APIPA address 169.254.0.10 like that. Now tell me here. The PC2 IP address is 192.168.1.3. The PC3 IP address is 169.254.0.10. This is the APIPA address. This is the actual IP received from the DHCP server. Now, these two can communicate or not? These two cannot communicate because both are different networks. But what is the use of this APIPA address? If this PC is unable to communicate with any other computers, but what is the use of this IP? What is the need of this IP? What is the use of this? What is the use of assigning APIPA address? What is the advantage of assigning this APIPA address? Okay, it's very simple. Okay, see, listen carefully. So discovery message is which message? Discovery message is the broadcast message, right? Broadcast message means every other PC receive this discovery message, right? If any one PC send discovery message, in that network, all the computers receive the broadcast message. All the computers receive the broadcast message. For example, this PC has sent discovery message and it is not getting response, means offer message. Again, it will send. If it is sending again and again, what happen? Every computer receive the number of times, right, broadcast messages. This is the problem in the network. So this broadcast message consumes network bandwidth, and also by receiving this broadcast message by again and again, system load also, system performance also will degrade. This is the problem with the broadcast message. To avoid this problem, system will assign APIPA address. Once it assign APIPA address, it will stop sending discovery message. Remember this point, very, very important. Okay, this APIPA address controls broadcast traffic. This APIPA address stops system from sending broadcast messages. Right. So this is about DHCP. This is about conversation between DHCP client and server. Okay. So in class B, we have 169.254.0.02. 169.254.255.255 is reserved for APIPA. In the class C, we don't have any reserved IPs. In the class D, total multicast IPs. In the class E, the last IP address is a broadcast IP address 255.255.255.255. It is broadcast IP address. It is what? Broadcast IP address. Remember this point, broadcast IP address. So whenever PC sends broadcast message, system will use this IP address as a destination IP. Right, here discovery message, right? For example, when this PC sends discovery message, in the discovery message, what is the source IP? Source IP, this PC has no IP address, right? Initially, whenever this PC is sending discovery message, so that time this PC doesn't have any IP. So here what happened? The source IP is always 0.0.0.0. Remember this point. 0.0.0.0 IP address used as a source address when it is sending discovery message. The next one, what is the destination IP? The destination IP is 255.255.255.255, right? It is a broadcast IP address, means This PC sends this message to everyone who is DHCP server, like that. So if destination IP is 255.255.255.255 means that message will be would be received by PC2, that message would be received by PC3, that message would be received by server also. All the computers will receive that message. This is broadcast IP address. So this is about IP address topic. Okay. So if you have any doubt in all the sessions, session 1, session 2, session 3, session 4, in IP address class, if you have any doubt, if you have any query, please send your queries in Q&A session or in comment. Okay, I will definitely respond and I will definitely answer your questions. Okay, thank you.